Hey there, I'm Malin Kramer from Edinburgh Napier University, and if you watched some of my earlier videos, you saw that we found out that houses are sometimes demolished just because they are in the wrong place at the wrong time and not because they are actually broken or anything. Today we are following up on that and we will provide a solution for this rather wasteful approach. What if we could just deconstruct and move houses instead of demolishing them? In the InFutureWood project, we conducted 5 case studies in 4 of our partner countries, and we had a look at just that. How well can contemporary houses already be deconstructed, and how can we improve the design of these houses so it works even better? I will have a look at the case study of the UK. Here we see the case study building. It's called Everett Grant and it's manufactured by Robertson Timber Engineering. It is currently being built in the south of Glasgow, south of Scotland, also south of Glasgow, yeah, in Scotland anyway. It's a rather big house with 3 floors and 5 bedrooms and 5 bathrooms, and it is a very typical example of Scottish building systems because it's a light timber frame system. To understand how we would deconstruct such a building, it's useful to understand the structure a bit better, so let's have a quick look at the structure. As I said, it's a light timber frame construction and it's partly off-site manufactured, which means that some components are pre-manufactured in a factory. For example, the wall panels come as 2D wall panel elements, which are comprised of studs with an OSB sheathing. On site, they are finished with insulation, a vapor control layer from the inside and a breather membrane from the outside, which are just like plastic foils. And from the inside some battens are attached to form a service cavity, so all the services on the inside run inside this service cavity. And then finally a plasterboard is attached on the inside. The wall panels are mounted on sole plates and are connected with hand binders. The floors come as pre-made cassettes, which consists of floor joists which are I-joists, covered with an OSB layer. On site they are finished with a chipboard floor cover, and from below the ceiling is also covered with plasterboard. The roof is made from pre-manufactured trusses, which are assembled actually on the ground. To form the roof structure they are connected with purlins and temporary bracing, and then the whole roof is lifted on top of the house, and there it is finished with roof felt and tiling battens. From the inside, insulation is fitted and the floor is covered with chipboard and the walls are covered with plasterboard again, and the roof is finally covered with concrete tiles. And this already makes our case study building, well, okay, there are still some finishes like doors and windows and outside block work, but here it stands. So how would we go about taking it apart again? This is what we asked Nicola Jackson and Mike Troner from Robertson Timber Engineering, and we came together and we imagined that in 50 years time this building has to be taken apart and moved and can be re-erected in exactly the same configuration. We imagined which deconstruction steps we would take and which damage we would expect to happen to the timber elements and which other obstacles we would face in the deconstruction. And we focused very much on the load-bearing timber structure. So let's have a look inside just to make it a bit easier. If we could really remove the wall panels that easily, that would certainly be a plus. But yeah, in a real deconstruction we will probably first remove the finishes like furniture and second fix items like light switches and so on. And then we could already remove the plasterboard which is screwed in onto the wall panels and ceilings. That would then expose the service cavity on wall panels and we could detach the services. Afterwards we could remove the external layers of the house, which are the blockwork and the roof tiles, and these layers would most likely suffer damage in the process. We could not reuse them, but the timber structure would stay damage free. The house would then look like this. The connection between timber elements is mostly nailed. So we would need to saw these connections apart, and we could now saw apart the connection between roof trusses and head binders of the first floor wall panels. After we have sawn them apart, we could lift off the whole roof and reuse the whole roof structure. We might need to saw it apart in places for easier transport, but this damage could be fixed on a new construction site. The first floor wall panels, exactly the same. We have to saw through the sole plates of the wall panels, and the sole plates would be damaged in the process, but the panels themselves can be reused as they are. And they can even stay connected in some instances, and the windows can stay inside, and even more layers can stay inside the panel compared to when they were first delivered to the construction site. So we see that the insulation can stay, even windows and doors can stay inside the panels, and if they are still in good condition. The intermediate floors can be lifted off after we saw them apart. So we have to saw through the chipboard floor cover to separate different floor cassettes, but this small damage can be mended on the new construction site, and they can be reused as a whole as well. And the ground floor walls, exactly like the first floor walls, we saw them apart, we saw through the sole plates, and we can reuse them as they are. Only the sole plates cannot be reused. Which means that in summary, we can reuse already 95% of the structure. And that means that obviously the system is already quite well prepared for deconstruction and reuse. It has several advantages. For example, it's made from large pre-manufactured components, and obviously it's easier to recover the roof like this compared to individual roof trusses. You have fewer deconstruction steps, which means less energy and time is needed, and you have less risk to introduce damage. So large components are a plus. Another advantage is that the company already has the knowledge and infrastructure in place. So the deconstruction is basically a reverse construction process, which means the same tools and knowledge are needed. And we could also imagine that if some of the modules suffer damage, they can just be diverted to the factory and be repaired there. Of course, the system also shows some weaknesses. First, the nailed connections are not ideal. We assume that they can be sawn apart, but this is probably not the most controlled or safe process. So if we could just replace the on-site nails with screws, that would make our life much easier. Secondly, the modules are highly complex. There are 75 different types of wall elements found in one building. If we could standardize this a little, we would just open up more reuse options. So if we manufactured the walls from standard units, we would guarantee that they have standard lengths, standard openings like windows and standard dimensions, and standard stud spacings. And all of this just make the reuse options more controlled and more standardized. So yes, that would be a benefit. In summary though, we can deconstruct and reuse our timber houses already, in theory. Obviously, we based all this on assumptions, and these assumptions need to be verified in some practical deconstruction studies. On the other hand, it would certainly not be the first time that someone took apart a timber house and reused the parts, so we are fairly certain that deconstruction would be an option for these timber houses. A different question is if this will really become mainstream practice relatively soon. Because obviously the houses we are building now will still be around in 50 years, and we would really expect that by then it's standard practice to deconstruct and reuse houses. Again, fingers crossed. So manufacturers really need to start thinking about these kinds of things. We know that Robertson has a sustainability strategy that says they want to go beyond net zero by 2030. So there is a chance that some of our solutions will find a way into their business model. And if manufacturers really start thinking about deconstruction, this is probably already a big step in the right direction, because some of the problems that we associate with deconstruction would already solve themselves if you only have the intention to deconstruct houses. For example, the traceability and storing the information for a long enough time. This is easy. These problems are easy to solve if you just start thinking about it. The other side of the problem is the consumer side. We are not really sure if at the moment we are building houses where anyone would care to take them apart carefully at the end of their life. Only 12.5% of Londoners think that modern houses are built with good design and modern living requirements in mind. And I'm sure that Robertson's customers value their luxury homes, but my living requirements would not be met with a 5-bedroom, 5-bathroom house. At the same time, 36% of new home buyers think that UK houses are too uniform and samey. Of course, we need to build beautifully and practically to make people value their houses enough to preserve them and deconstruct them maybe in the end of their life. But beauty and practicality probably mean different things for different people. So we also need to think about other things, not only deconstruction. We need to think about adaptability and probably things like biophilic design and so on. We see that this problem is highly complex. On the other hand, our proposed solutions are not exactly rocket science either. So if we really start to think about design for deconstruction now, we will have a much easier time in 50 years, and we will prolong the life of timber buildings, of timber elements, and we will avoid a lot of waste.